Okay, on the board in front of you there is a question. It's a very simple question. This is pretty much as simple as it gets for utilising Snell's law. And later on in this video we're going to do a much more complex example utilising both Snell's law and the critical angle. So what we've got here is a situation where we know what the angle of incidence of the light of ray in the air is to the normal, and we know what the angle of refraction is. So we want to determine what the refractive index of the glass is. So what is the refractive index of the glass? Well, first of all, we need to write out Snell's law as N1 sine theta 1 is equal to N2 sine theta 2. So what of these values can I throw in there straight away? Well, I know N1 is 1 because air has a refractive index of 1. So that's a constant that you do need to take with you do need to know about. Glass N, well, we're going to look to see if we can find out that. That's going to be our N2 in this case. Air was N1. And we don't know what that is. That's what we're looking to find out. And then it's just a matter of filling in the rest of the blanks. So, N1 is 1, so 1 times sine theta 1 is just going to be 1. So for all intents and purposes, we can actually get rid of that 1 that's right there. Then what we can do is we can say, okay, well, we need to work out what N2 is. So we need to divide both sides by sine theta 2. It might be helpful at this point to write in the numbers. So sine of 32 is equal to N2, which is our unknown, sine of 21. Rearranged, that's going to give you sine 32 divided by sine 21, which we'll work that out in our calculator. So sine of 32 divided by sine of 21. That gives you an answer of 1.4787, which is basically 1.48. Okay, so that is the refractive index of the glass block, 1.48. But we can take this a step further, because what can we do with a refractive index? Well, we can utilise a refractive index to help us work out what is the speed of the light in this glass. Well, N is equal to C over V, so therefore V will be equal to C over N. 3 times 10 to the 8 is the constant C divided by 1.48. And I'll use the more accurate value that's in my calculator to work this one out. So I'll do 3 times 10 to the 8 divided by previous answer. So that gives us 2.03 times 10 to the 8, but we'll go with pretty much 3 significant figures here, 2 significant figures here, so we'll probably go with 3. We get away with 3, so 2.02 times 10 to the 8 meters per second. So that is the speed of light in that glass block. Right, so in the next example, I'm just going to rub this one out, and we're going to have a go at putting even more stuff together in a more complex example.